Mastery practice questions number 1. These are the three consecutive terms of an arithmetic progression. So A, we want to find the common difference. So common difference of an arithmetic progression is the difference between any two consecutive terms. So for questions A, we want the common difference, which is the D. So first I can find the common difference, the D one, using these two terms. So it's going to be 3x plus 2 minus, I'm going to put a bracket because I'm going to minus the whole thing of negative 2x minus 1. So here is going to be 3x plus 2 plus 2x plus 1. Then we're going to solve for the like terms. It's going to be 5x plus 3. We can also find the common difference of these arithmetic progressions using these two terms. So I can use 9x plus 3 minus 3x plus 2. So here is going to be 9x plus 3 minus 3x minus 2. So solve for the like term is going to be 6x plus 1. The common difference is a fixed constant. Therefore, the value of the D1 is going to be equal to the value of the D2. Therefore, 5x plus 3 equal to 6x plus 1. We're going to solve for the x. It's going to be 3 minus 1 equal to 6x minus 5x. Therefore, x is equal to 2. Now, to find the common difference, I'm going to substitute the x equal to 2 into D1. Therefore, the common difference is going to be 5 times 2 plus 3, which is equal to 13. If you sub the x equal to 2 into the D2, you're going to get the same result as well. Now, let us solve for questions B. The first term, which is the A, if 3x plus 2 is the third term. So here we know that the third term is equal to 3x plus 2. To find for the third term, we can use the formula a plus n minus 1. Here the n is going to be 3 minus 1. And the d is equal to 13. Here I'm going to replace the x with number 2. So here you're going to have a plus, so 2 times 13 is going to be 26. So here you will get 8. Therefore, a is equal to 8 minus 26. So the first term here will equal to negative 18. Questions number 2. The ninth term of an arithmetic progression is 21 plus 3p, and the sum of the first three terms is 9p. So find the common difference. So here we're going to use these two formula to help us to solve for this questions number 2. So this 21 plus 3p is the T9, and this 9p is the S3. So for the first informations, we know that T9 is equal to 21 plus 3p. To find the T9, we're going to use this formula. So it's going to be a plus, here the n is going to be 9 minus 1, d equal to 21 plus 3p. So solve this, you're going to get a plus at d equal to 21 plus 3p. So this is for the first information. The second one is going to be S3 equal to 9p. So for the S, we're going to use this formula. Then it's going to be 3 divided by 2, bracket 2a plus, so here the n is going to be 3 minus 1d equal to 9p. So next I'm going to move this 3 over 2 to the right hand side. So therefore on the left hand side I'm going to get 2a plus 2d equal to 9p times 2 over 3. So simplify this. So on the right hand side you're going to get 6p. So here I can continue simplify it by dividing every term with number 2. Therefore, a plus d equal to 3p. So now let us focus on these two equations that we have here. We can solve these equations by using the simultaneous equations method. So let this as equations number 1 and this as our equations number 2. So now I'm going to use equations number 1 minus equations number 2. So when a minus 8, it will be cancelled. So at d minus the d, we're going to get 7d. So here is going to be 21 minus 0. So we're going to get 21. 3p minus 3p, it will be cancelled as well. Therefore, d will equal to 21 divided by 7. So the common difference d is equal to 3. Questions number 3. The diagram shows 3 cylinders such that the volume of each cylinder is arranged according to arithmetic progressions. The sum of the volume of the first and third cylinder is 24 cm cubed, and the volume of the fifth cylinder is 36 cm cubed. So A finds the volume of the smallest cylinder. Again, we're going to refer to this formula. So the volume of the smallest cylinder. So this one is actually refer to the first term, which is the A. So from these informations, we know that the first volume is going to be the T1, which is the A, and the third volume is going to be the T3. So when we plus it, sum it up, it's going to equal to 24. So for A, we know that T1 plus T3 equal to 24. And T1 is the first terms, and this is the same as A. And as for the T3, we're going to solve it using this formula. So it's going to be A plus 3 minus 1, which is 2D here, equal to 24. So A plus A is 2A plus 2D equal to 24. Next, I'm going to divide every term with number 2. So A plus D equal to 12. So this is the first equation. Next, from this information, which is the volume of the fifth cylinder, which is the T5, we know that it is equal to 36. Again, refer to this formula. T5 is equal to A plus 5 minus 1, which is 4. So 4D equal to 36. So this is the second equations. So I'm going to label this as equations 1 and this is equations 2. And we're going to use the eliminations method in simultaneous linear equations to solve for the A and D. So here I'm going to use equations number 2 minus equations number 1. So A minus A, it will be cancel. 4D minus D, you're going to get 3D. 36 minus 12, 24. So D equal to 24 divided by 3, which is equal to 8. And to find for the A, which is the volume of the smallest cylinder, I'm going to substitute the D equal to 8 into the first equations. Therefore, A plus 8 equal to 12. So A equal to 12 minus 8, which is equal to 4. So that is the volume of the smallest cylinder. As for questions B, calculate the sum of volume for the first 9 cylinder. This is referred to as 9. To find the sum, we're going to use the second formula here. So S9 equal to 9 over 2 bracket. Now I know that the A is equal to 4 and my D is equal to 8. So here is going to be 9 over 2 times 72. So answer will be 324 centimeter cube. Questions number 4. The third term of a geometric progression is 30 and the sum of the third and the fourth terms is 45. Find A, the first term, and the common ratio. So for geometric progressions, we're going to refer to the formula that I have here. So the first information, the third term is equal to 30. So T3 is equal to 30. So we're going to refer to this formula to find the T3 is going to be AR. The n minus 1, 3 minus 1 is equal to 2. So this one will equal to 30. The second information is that the sum of the third and the fourth term is 45, which means T3 plus T4 is equal to 45. Now we know that the third term is equal to 30, therefore this T3 is equal to 30. T4 again refer to this formula. It's going to be AR 4 minus 1, 3 equal to 45. So AR to the power of 3 is equal to 45 minus 30, which is equal to 15. Next, I'm going to label this as equations 1 and this as equations number 2. Now, to find the common ratio, I'm going to use equations number 2 divide by equations number 1. So it's going to be AR to the power of 3 divided by AR squared equal to 15 divided by 30. So here the A will be cancelled. So R to the power of 3 divided by R to the power of 2 is equal to R. 15 divided by 30 is 1 over 2. So the common ratios R is equal to 1 over 2. And to find the first term, which is the A, I'm going to substitute R equal to 1 over 2 into equations number 1. Therefore, A bracket 1 over 2 square equal to 30. So here you want to have 1 over 4. Then I got to move this 1 over 4 to the right hand side. So A equal to 30 times 4, which is equal to 120. Now for questions B, the sums to infinity, then we're going to refer to this formula. So the A is 120. The R is 1 over 2. So substitute into the formula and solve this, and the answer is 240. Questions number 5. The diagram shows the arrangement of a few chairs. The height of each chair is 80 centimeters. When the chairs are arranged, there is a 4 centimeter gap in between two chairs. The arranged chairs will be kept in the store. A. Find the maximum number of chairs that can be arranged if the height of the store is 3 meters. So first, we need to determine whether the arrangement of the chairs here is going to form an arithmetic progressions or geometric progressions. So the first chair, the height of the first chair is going to be 80 centimeter. So this 80 centimeter will be the A, the first terms. And there is a 4 centimeter gap between two chairs. So after you stack the second chairs, you're going to have a 4 centimeter gap here. So for questions A, the first term is going to be 80 centimeter. And when you stack the second chair plus another 4 centimeter, the height is going to be 84. So when you stack the third chair, there is going to be another 4 centimeter gap between them. Therefore, now the height is going to be 88. Now, based on this, we can say that the arrangement of chair is going to form an arithmetic progressions with the A 80 and 4 centimeter here is going to be the common difference. And the maximum number of chair here is the n that we want to find. And the height of the store is 3 meters. So this 3 meter, we can convert it to centimeter. It's going to be 300 centimeter. This 300 centimeter will be the last terms. Now to find the n, so Tn equal to 300. So now refer to this formula. So here the A is going to be 80 plus n minus 1. Now the D is equal to 4. To find the n, first I'm going to move the 80 to the right hand side. So it's going to be n minus 1 times 4 equal to 300 minus 80, which is equal to 220. Next, I'm going to move this number 4 to the right hand side. So 220 divided by 4, you're going to get the answer of 55. Then n equal to 55 plus 1, which is 56. So the maximum number of chairs will be 56. So you stack it and then it's going to reach the height of the stove. Now for questions B, I do believe there is some missing words here. So this should be 13 stack of chairs. Will be kept in the store with the conditions that the first stack will have the maximum number of chairs and the arrangement of chairs for the subsequent stacks decreases by 2. So calculate the total number of chairs kept in the store. So for questions B, we're going to have 13 stack of chairs. So the first stack here is going to have the maximum numbers of chairs. So let's say this is the second one and this is the third one until the 13th stack of chair. So the first one we're going to have 56 chairs, which is we already find the maximum number of chairs in A. And for the second stack, it's going to be decreased by 2. So next we're going to have 54 chairs. And for the third stack, after decreased by another 2, we're going to have 52. So this is also going to form an arithmetic progression with the A of 56 and the D of -2. So when you want to find the total number of chairs, then we're going to use this formula, the Sn. So now we know that we're going to have 13 stack of chairs, so the n is equal to 13. So S13 equal to 13 over 2 bracket. Now the A here is going to be 56 plus 13 minus 1, the D is going to be -2. So here we're going to have 13 over 2. Solve everything inside the bracket, then you're going to get 88. Multiply it with 13 over 2, then you're going to get the number of chairs is equal to 572. Questions number 6. Injured Muslim starts to save Rm 14,000 into his newborn baby's account. The banks offer a 5% interest yearly. Injured Muslim hopes that his child's saving will reach Rm 30,000 when his child becomes 18 years old. A. Do you think he can obtain Rm 30,000 when his child becomes 18 years old? Show your calculations. So A, first we need to determine whether the amount of money in the bank each year will create an arithmetic progression or geometric progression. So A, let's look at how to calculate the amount of money in the bank each year. So for the first year, the amount of money inside the bank will just be 14,000. As for the second year, the amount of money will be the principal, which is the 14,000 plus this 14,000 will be given a 5% interest. So we're going to multiply it with 0.05. As 5%, you divide it by 100. So the amount of money will be 14,000 plus the interest, which will be 700. So the total amount of money in the second year will be 14,700. And as for the third year, this 14,700 from the second year will be given another 5%. So we're going to multiply it here with 0.05. So the interest for the third year, you're going to get 735. So plus with this 14,700, you will get 15435. So now let us try to find the patterns here. Now from the second year, this 14,000 which coming from the first year, this is actually the 100% amount. And this 700 is the interest of the 5%, which means this 14,700 is 105% more compared to the amount in the previous year. So in other way to set this 14,700, you can calculate it by taking the amount of money in the first year and then you multiply it with 105 over 100. So it's the same meaning as 14,000, you times it with 1.05. We also get the amount of 14,700. Now, look at the third year. This 14,700 which come from the second year, this is also the 100%. This 735 is the 5% interest. So the amount of money, 15435, this is the amount 105% from the previous year. We can also calculate this 15435 by using 14700. We're going to multiply it with 105 over 100. So it's the same meaning as you multiply it with 1.05. Now, this 14700 is the amount of money in the second year. So the amount of money in the second year, you can calculate it using 14,000 times 1.05. So I can replace this 14700 with 14,000 multiplied by 1.05. So now, if you look at here, it started going to create a pattern here. 14,000 times 1.05, 14,000 times 1.05 times 1.05, which this one is the same as 14,000 times 1.05 to the power of 2. Now, as you multiply the previous number with 1.05, this is going to create a geometric progression. So here, this 14,000 is the A, the first terms. And as for the R, as you multiply it with the constant number 1.05, so the R will be 1.05. So now, we want to know whether Inject Muslim can achieve 30,000 of saving when his child becomes 18 years old, which means now we're going to find the 18 terms. So we're going to use the formula AR n minus 1. So here the A is going to be 14,000. The R is going to be 1.05. So n minus 1 here will be 18 minus 1, which is 17. So multiply this, you're going to get the amount of money will be RM 32,088 ringgit and 26 cents. So yes, Inject Muslim can obtain RM 30,000 when his child becomes 18 years old. Questions B. If the interest decreases to 3% per year after 10 years, calculate the total saving when Inject Muslim child is 18 years old. Can the saving of his child reach RM 30,000? So for questions B, from the first year to the 10 years, so the bank will still offer a 5% of interest rate yearly, but after 10 years, until the child reach 18 years old, which is the 18 years, the interest rate will only be 3%. So in order to calculate the amount of money after 10 years, we're just going to use the method in A, as you still have the same interest rate and the principal. So in the questions A, if you still remember, the A is 14,000 and the R is 1.05. So the amount of money Inject Muslim save in the 10th year, which is the T10, is going to be 14,000 times R, 1.05. So the n minus 1 here will be 9. So after 10 years, the amount of money will be 21,718 ringgit and 60 cents. So after 10 years now, the interest rate is decreases to 3% yearly. So now, here in the 10 years, the amount of money is 21718.60. And as for the 11 years, this amount will be given a 3% interest. Now, using the patterns that we learned in A, so to calculate the amount of money in the 11 years, it's going to be 21718.60 times 1.03. And in the 12 years, the amount of money will be 21718.60 times 1.03 to the power of 2. Now, according to these patterns to calculate the amount of money in the 18 years, so here we're just going to use T8. So this will be the A, the 18 years will be the last term, right? So T8, the A is 21718.60. Now the R is going to be the 1.03. So the n minus 1 will be 7. So calculate this, you're going to get RM 26,711 ringgit point 14 cents. So can the saving of the child reach RM 30,000? No, in this case. Questions number 7. Shahruz has a toy car collection which he collects every month. The number of toy cars increases every month according to geometric progression. The total number of toy cars in the first 4 months is 10 times the total number of toy cars in the first 2 months. So there is a missing words in the textbook there. So A, if R represent the common ratio, show that R to the power 4 minus 10R squared plus 9 equal to 0. Hence, finds the positive value of R. So here we're going to use this formula, the sum of the geometric progressions, to help us to solve for the questions A. Now, from these informations, the total number of cars in the first 4 months, so this is referred to as 4. It is 10 times the total number of toy cars in the first 2 months. Therefore, it's going to be 10 times as 2. Now, to find the total number of cars in the first 4 months, using this formula is going to be A bracket R to the power of 4 minus 1 over R minus 1 equal to 10 times A R to the power of 2 minus 1 over R minus 1. From here, we can do the cross multiplications. So it's going to be A bracket R to the power of 4 minus 1 times R minus 1 equal to 10A bracket R squared minus 1 times R minus 1. So from here, we can cancel the A and the R minus 1. Therefore, next we're going to have R minus 1 equal to, here we're going to expand this, it's going to be 10R squared minus 10. So move everything to the left hand side, therefore you're going to get R to the power of 4 minus 10R squared. So negative 1 plus 10, you're going to get positive 9 equal to 0. So by that, we already shown that the equations in A. Next, we want to find the positive value of R. So this one we can solve it just like the quadratic equation. So first we're going to do the factorizations. So from here we're going to get R squared minus 1, another bracket is going to be R squared minus 9 equal to 0. So now to find what is the positive value of R. So here, next, so R squared minus 1, this one will be equal to 0, or R squared minus 9 equal to 0. So R squared equal to, so this negative 1 move to the right hand side will be a positive 1. So when you move the square to the other side, it will be plus minus the square root of 1. And as the question asking you to find the positive value of R, therefore we're going to ignore the negative 1. So the square root of 1, so R is going to be equal to 1. Another one is R squared equal to 9. So we're just going to take the positive value, so just square root the the 9, then you're going to get R is equal to 3. Now, if you look at the formula here, you're going to notice that the R cannot be equal to 1, because when the R is equal to 1, then the denominator will be equal to 0. So therefore, we're going to reject the answer of R equal to 1, and the positive value of R here will be equal to 3. Next, questions B. Calculate the expenses paid by Shahrul in the 6 months if he started to buy 2 toy cars and the average price of a toy car is Rm 7 ringgit and 50 cents. So these 2 toy cars will be the first terms of the geometric progressions. Therefore, this will be the A. And from the questions A, we already find that the R is equal to 3. So to find the expenses, first we need to find the total number of cars that Shahrul bought in 6 months. So for questions B, first we're going to find the S6. So now we know that the A is equal to 2. The R is equal to 3. So for the 6 months here, it's going to be 3 to the power of 6 minus 1 over 3 minus 1. So solve this, you're going to find the total number of the toy car will be 728. Now to find the expenses paid by Shahrul, then we're going to take this total number of toys car, multiply it with 7 ringgit and 50 cents. So it's going to be Rm 5,460.